Hello, I want to go over chapter 5, statistic. This chapter is about discrete probability and discrete probability distribution. So in the beginning, we're talking about two, if it's clear or not, two definitions in this section. One is a random variables. A random variable is a variable that has a single numerical value, and probability distribution is description that gives the probability for each value of random variable. And then here is the difference between discrete random variable and continuous random variable. The main difference between these two is discrete always take the whole number, and continuous can take a decimal number. This is examples. Count of number of movie patrons. How many people enter the movie theater is a whole number, so it's a discrete. Or number of patients who walk into doctor's office are discrete. Or number of people or customers who walk into the bank. So these are all examples of discrete because it cannot take a decimal. But continuous random variable, they can take a decimal. Like here is a voltage or temperature. You know, what's the temperature today? It's like 68.7 degree of Fahrenheit. And here, anything that can take any item can take a decimal is a continuous variable. Then here I show you some good examples for you to see. You have a copy. I already put a copy of these documents on Canvas. So like here, we ask you to tell, like here, part A is the number of statistic students now reading a book discrete, random, continuous, or not a random variable. So number of statistic students is the whole number. It cannot be decimal. So that would be number A, discrete. B, is the square footage of the house a discrete, continuous, or not a random variable? It is. You know, when you find square footage of your house can also take a decimal number. You know, it's 300.7 square feet. So that would be a continuous. And C is political party affiliation of adults in the United States is discrete, random, continuous, or not a random variable. It's not a random variable. It's not something that you could measure. D, number of people with blood type A, number of people. So it's discrete. E, is the exact time it takes to evaluate 27 plus 72. It's talking about the time. Time can also take a decimal. Is 21.7 minutes. Okay, so again, the main difference between these two is that discrete has whole number and continuous does not. Now, before we go over probability distribution, I put an example for you. Now, let's say there are 10 students in a stat class, and I have listed all the grades here. How would you take the average? You know, in the statistic, we don't call it average, right? We call it the mean. How do I calculate the mean? To calculate the mean, you add all these numbers, sum of x divided by how many do you have? 10. So that gives you mean is 82.8. Now, I want to introduce probability distribution table. Probability distribution table is another way of doing the calculation for mean and also standard deviation. So the way it works is you write the x here, so you don't have to repeat 10 numbers here because you know that 70 How many 70 do I have? 1, 2, so frequency is 2. How many 78 I have? Just 1, so frequency is 1. How many 80s? 1, 2, 3. So 80, the frequency of 80 is 3, and so on. And then you calculate probability of X, which is relative frequency. Remember, to calculate relative frequency, you take each number and divide by the total number, which in this case is 10, sum of F. Now, when you have probability distribution table, you want to make sure that sum of the probability is always 1. This is one of the requirements of probability distribution table. Sum of probability always has to be 1. And then we have a formula that when we, in chapter 5, in this one, see, a copy of this is on StatLab. If you want to calculate probability distribution, mean of probability distributions is sum of XPX, and a standard deviation is that, okay? So to calculate probability distribution mean is sum of XPX, means you create a new column which is X times PX, means you take this PX and multiply by X. See, so first one is 0.2 multiplied by 70. That will give you 14. X times PX, or the second one, X is 78, multiply that by 0.1, give you 7.8, and so forth. So, mean is sum of numbers in this column. How do I calculate the standard deviation? A standard deviation is x2 times px. So I need to create another column, which is x2 px. That means you take xpx and multiply by x. See, x times xpx is x2 px. So how do I come up with 980? 70 multiplied by 14 is 980. Or 78 multiplied by 7.8, it gives you that. You find sum of x2 px, which is right here. So sum of this is there. You take all this and plug in the formula to find a standard deviation. So this is a formula for mean of probability distribution table, and it's a formula for a standard deviation of probability distribution table. With another example, again, first I want to show you how we calculate a mean and a standard deviations just using the chapter 2 method. You know, we have this formula already, sum of x2 . So in chapter 2, we had the formula right here in chapter 2. See, this is a standard deviation, and this is a mean. In chapter 3, I'm sorry, chapter 3. Okay, so now, first, we go ahead for this example, we calculate a mean and a standard deviation. Now, here, I want to show you how we can also do the problems using the table, probability distribution table. So you could write it as a frequency, okay? So that's an example of that. So problem like this, there are two ways to do it. One through the frequency table, one through just this formula. Now, we have a definition, they call it expected value. When you do the probability distribution, expected expected value of a discrete random variable is denoted by E, which is the average. You know, what we have as a mean here in this section, they call it expected value, which is basically is the mean. Now, I made an example here to show you where we use all this. Let's say a couple want to have 2 kids. For the first kid, this is a tree diagram. When the first baby is born, is either boy or is a girl. And probability is always 50%. So if it's a boy, is half. If it's a girl, is half. Now, let's assume the first baby is a boy. The second one could be a boy or could be a girl. So probability of both of them are boys, you go and multiply half by half. Boy, boy, which is 25% or 1/4. If the first one is boy, the second one might be a girl. So what is the probability of the first one is a boy and second one is a girl? The same thing. And if the first one is girl and the second one is a boy, then the first one is a girl and boy, so the probability remain the same for all of them, okay? Now we want to have probability distribution table. What's the probability of, now we look at all these 4 options here. What's the probability of couple have no girls? No girls means both of them boys. So it's 25%. Probably it's 25%. What's the probability of one of each? One girl and one boy. You have one here and one here. So 25% and 25% is 50%. What's the probability of both babies are girls? Girls and girls is 0.25. We write that here. Okay. Again, if you want to make sure this is a probability distribution table, you gotta check. This is one of the conditions. Sum of Px must always be 1 or 100%. And then we calculate xpx, x2px, and you see that mean, we already know mean is sum of xpx, which in this case, when we calculate sum of xpx is 1, which also here we call it expected value. Expected value and the means are the same thing. And then we calculate a standard deviation is x2px minus that, so we put all those. Okay. Now, what are the conditions when we give you a problem and we say solve this probability distribution table? One of the conditions is you want to check to make sure that sum of Px is always 1. See, in this example is not 1, it's 0.66. See? So this one violates probability distribution. So we cannot use the formula for these problems. So when we give you a problem that we ask you to calculate mean and standard deviation for probability distribution, first you need to check to see if sum of Px is 1 or not. These problems let me see if I can focus. So this problem, x value is not numbers. So this table violates the first requirement because x is not a numerical random variable. See, this x has to be a numerical value. See these problems here? See how you have x is always a numerical value here? So that's one of the conditions. You want to make sure that x is numerical value. So this one, and see this one violates both rules. This is not numerical value, it's not a number, and look at here. And sum of Px is not 1, it's 1.57. So this is not probability distribution table. You know, in chapter 2, when you draw your histogram and you connect it and create a bell-shaped curve, there are 2 points that if your number go beyond this or lower than this, call it unusual, those numbers. How do you find those numbers? In the problem, when we give you the mean and the standard deviations, you take mean and add and subtract standard deviation of the sample to it. That gives you these 2 points. So any number above this or below this is unusual. And that's what they discuss here. So that's when significantly low, significantly high. This is very important. Anytime during this class, when you calculate the probability, if the probability is less than 5%, that probability is unusual. So you want to make sure probability is always greater than 5%, not less. The next is, we call it binomial probability distributions. You know, binomial probability distribution is one particular category of discrete probability. And there are 4 conditions. One is, when you give you a probability distribution, how do you know it's going to be this binomial probability distribution? You have to have this rule. You have to have fixed number of trials, trial must be independent, outcome always should be 2 category, and so on. Look, example, flipping a coin is a good example of why. Flipping a coin, let's say you flip the coin 10 times and you don't change it. The trial must be independent. When you flip a coin, if you flip it 10 times and 6 or 7 times you get head, does that mean 8 is going to be tail? No, the trials are all independent. You might, you know, it's like when you play blackjack, you know, if 5 or 6 or 10 times you get a black, it doesn't mean that one after that is going to be red. Trial is always independent. Outcome is 2 category. When you flip a coin, you either have tail or head. Or when you play blackjack and you put on red or black, is always 2 category. The second example is not a binomial. Rolling a dice 60 times is not. Why not? Because when you roll a dice has 6 faces, not just 2. So it's not example of binomial. Now, this is a formula that we use very often when we want to calculate the probability. It's a binomial formula. And I'll show you some examples for that. And so for normal distribution, if we ask you to calculate the mean, we discussed on the previous example, mean is always sum of x, bx, and the standard deviation is from this formula. There is a special kind of binomial distribution that we discuss, and that formula are kind of different. So here, in chapter 5, we have probability distribution. That's how to calculate the mean, a standard deviation, and probability. But in a special case, if it's binomial, then mean is n times p, and the standard deviation is radical npq. When we go over the example, then you understand the difference of these two. That's a special case of binomial, which we are using this formula. So for mean, we don't use sum of x, bx. We just say take n multiplied by p, and this is the standard deviation, n times p times q. Okay, all right. So discuss this formula here. In this formula, n is number of trials, x is how many, what's probability you're looking for. And they have a value of p, which is we call it probability of success, and q is always 1 minus p. Okay, so let's look at this example. There is 0.85 probability that randomly selected adult knows what Twitter is. Use the binomial probability formula to find the probability when 5 adults are randomly selected, means n is 5. Exactly three of them know what the Twitter is. So what is the probability of 3 out of 5? 3 out of 5. You have 5 factorial and 5 minus 3, 3. What is factorial means? Factorial, like if you ask you to calculate 2 factorial means 1 times 2. What is 3 factorial? 1 times 2 times 3. What is 5 factorial? You just start from 5 times 4 times 3 times 1, and you also have that on your calculator. So on your calculator, CI44, if you go second verse, is under math, I'm sorry, that's right. You go to math, M-A-T-H, and you go to probability, that's where the factorial is, number 4, okay? So let's say you want to find, let's try something that you know the answers, like let's see what 5 factorial is. 5 times 4 is 20, 20 times 3 is 60, times 2 is 120. 5 factorial is 120, okay? So I want to use the calculator for that. So you type 5 first, and then you go to math, M-A-T-H, scroll to the right to probability, scroll down to number 4, 5 factorial. See that? And then enter, it give you that 120, okay? So you don't have to do hand calculation for factorial. All right, so you take all these numbers, and what is P? P is, they call it probability of success. If you know the value of P, you don't have to know, we don't have to give you the Q, because Q is always subtract from 1, he give you that one. So Q is always 1 minus the value of P. Since the value of P is 0.85, then Q is 0.50, okay? So you put all these numbers, so you find probability of 3 out of 5. Now, here I also show you how to use the calculator to find this. You know, instead of using the formula, you could use the calculator. For the calculator, you go to the second verse. Second, you see the blue ones. And then verse here. Then binomial PDF. So scroll down all the way to find that. Binomial PDF is A. Enter. Trial, how many trials? We're trying to have 3 out of 5. So there is 5 trials. Probability of success is given in the problem is 0.85. And 3 out of 5, that's the X value, is 3. And then you paste it. One more. It should give you that number that you calculate here, okay? So if you understand how to use a calculator, make your life really easy for you rather than going through a large formula and do the calculation, especially when you're dealing with large number. And then I'll show you some examples here, you know, and see, like here, a student randomly guess at 5 multiple choice. So you have 5 choices, n is 5. Find the probability that the student get exactly 3. 3 out of 5. See, 3 out of 5. I show you how to use the binomial formula and how to use the calculator to come up with answers. And where do I get this value of P? When there are 5 questions or 5 choices, if you randomly select 1 out of 5, what's the probability that that one is correct? 1 out of 5. So probability of coming with the correct answer is 1 over 5. And Q is always, you subtract 1 over 5 from 1. So it's 4 over 5. That's where we are these numbers. Or in this example, a coin is tossed 3 times. What's the probability of, let's say, no head? You calculate here. You put probability of 3 and then 0. What's the probability of 1 and so on. So this formula helps you to find the value of Px from now on. You know, when we ask you to find the probability, there is also a table available, table A1. So if I have the n value is 5 and x is 3 and probability of success is 0.60, like that example we just did, you could also use table A1, which is at the end of the book, and calculate that. But table A1 is not very common anymore because it doesn't give you for all, what the number is really, really large. It's very limited for the n. You know, I think it's up to 10. So this is not very common, but at least you need to understand. For this example, if you have a table, if n is 5 and probability of x equal 1, 60%, it give you. Or you could use the formula for each. Okay? Or you could use the formula and calculate each value. So I'll show you all 3 methods here. So you want to read that and then let me know if you have any questions. So I introduced 3 methods to find the probability. Using a table, using the binomial formula or calculator. Second verse, binomial PDF. Then he asks you, what's your trial? 5. What's the probability of success? 0.6, and so on. Sometimes we ask you to do the accumulations. Like, there are 20 numbers. What is the probability of at least 12? That means you have to use a formula. Calculate probability of 12, 11, 10, 9, 8, all the way to 0, okay? So like that, rather than doing 12 calculation and using the formula, is best to use the table. I mean, the calculator. The calculator has a function which is C, cumulative. What it does, it calculates all the probability all the way from 12 to 0. And that's what it is. What if you want to find probability of x greater than 12? Means you want to find probability of x equal 12, x equal 13, x equal 14, all the way to x equal 20. If you want to calculate all these, what do you need to do? Since the calculator always do this part, okay, and some of the probability is always 1, what you could do, you could use your calculator and then to find probability x greater than 12, whatever you get from here, you subtract from 1 to find x greater than 12. And then I'll show you some other example here so you could practice. And here we talk about when you say significantly high number, low number, it has something to do with that 0.05. This is a mean and standard deviation. When you have a binomial distribution, a special case, when the problem is binomial, then you could use this formula. Okay, so I might discuss that on the next sections. So far we are on section 5.2.